Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. Today we are going to start a new chapter called Limits. One of the most important chapters if you want to understand and if you want to do well in derivatives and obviously other topics in differential calculus and obviously integral calculus. Okay, now let us see the introduction to limits and what are we going to see in this today's video. So we are going to understand limit of a function. To understand what is limit of a function, we should know what is neighborhood of any real number a, and after that we will talk about limiting value of a function. Limiting value of a function. And then we will see whether the limit exists or not. Okay, so we will talk about existence of limit. We will talk about existence of limit with few examples. Okay, now first let us talk about neighborhood of a. So neighborhood of any real number a. NBD means neighborhood of a. So to understand what is neighborhood of a, first we should ask ourselves one question. What is the smallest possible interval in which the real number a lies? Okay, now, so if you think about it, so for example, to understand what is the smallest interval, let us consider one positive real number delta. So it is positive, it is a real number, and at the same time, delta is approaching 0. The meaning that delta is approaching 0 is delta is infinitely smaller number. It can be 10 power minus 100 or it can be 10 power minus 1000, whatever it is. Okay, now understand that delta is approaching 0, 0.000000000 and so on. Delta is infinitely smaller number. If that is the case, dear students, the interval a minus delta comma a plus delta, the interval a minus delta comma a plus delta is called the neighborhood of a. So it is one of the smallest intervals in which the real number a lies. If you look at the number line, so here is a and somewhere here a minus delta will be there and here a plus delta will be there. So this is one of the smallest intervals in which the real number a lies. Okay, now this particular interval is called neighborhood of a and it is denoted by n delta of a. The neighborhood of a is denoted by n delta of a, which is same as a minus delta comma a plus delta. So dear students, what is the significance of the neighborhood of a we will learn when we discuss about limiting value of a function. But this is one of the smallest intervals in which the real number a lies. Next, if you observe one thing, this part from here to here, this region, this interval is called, we call it as what? We call it as left neighborhood of a. We call it as left neighborhood of a, and this interval is there now. This interval towards the right side of a in the number line a comma a plus delta. This is called as right neighborhood of a. So this is left neighborhood of a and this is right neighborhood of a. Okay, so you understood about the neighborhood of a, and at the same time, if I take the union of these two, the left neighborhood and right neighborhood, a minus delta comma a union a comma a plus delta, then this particular interval is called deleted neighborhood of a. Deleted neighborhood of a, which means that it is an interval from my a minus delta to a plus delta without a. Okay, now a is deleted from this particular interval, so we get deleted neighborhood of a. Okay, now you understood about neighborhood of a. Now let us discuss about limiting value of a function. Before continuing with limiting value of a function, a small example. What is neighborhood of some real number called 2? Let us see. For example, I want to know what is the neighborhood of 2. Then we can write like this. Let us consider delta. For example, approximately 10 power minus 60. 10 power minus 60. 10 power minus 60 means 0.000000 and so on. 59 zeros, then 1. Okay, fine. Then the neighborhood of 2, if delta is approximately this number, is given by what? 2 minus 10 power minus 60 comma 2 plus 10 power minus 60. And if you want to assume it in decimal numbers, it will be like 1.99999999 and so on. How many times? Maybe 60 times. And then this number will be 2.00000 and so on. 59 zeros and then 1 will come. So this is one such interval. This is, we can take it as what? Neighborhood of A. Fine. Sorry, neighborhood of 2. Now you understood what is neighborhood of 2, correct or not? So let us talk about limiting value of a function. Dear students, let us consider a function y is equal to f of x, whose domain can be real number. Let us assume that x can be any real number, whose domain is any real number, and at x is equal to a, at x is equal to a, we all know that the value of the function is what? If it exists, please understand this. So since we are taking a in the domain of f of x, we will assume that f of a exists. Then the value of the function, what is the value of the function? The value of the function is given as f of a. So for some functions, f of a exists as a finite number, sometimes it does not exist, okay now. So whatever it is, f of a is called value of the function. Then what is limiting value of the function? So to understand this, let us assume that x is not a, but x is approaching a. X is approaching a means, dear students, x is a value which is very near to a. If it can be just lesser than a, or it can be just more than a. So this means that x is approaching a. X is approaching a means x is a value which is very close to a. Okay now. So then when x is approaching a, then f of x approaches one number. Okay now. Let the number is L. F of x approaches one particular number. That particular number is called limiting value of a function. Limiting value of f of x. To write this mathematically, I will write like this: limit x approaches a f of x. It is equal to L. So when x is approaching a, when input is approaching a number a, then the output is approaching what number? L. So here sometimes the limit, this is called limiting value of a function. Sometimes you will get an answer, you will get a finite answer, sometimes you will get infinite answer. So only sometimes limit exists and sometimes the limit does not exist. To understand exactly when limiting value of a function exists and when it does not exist, let us talk about left hand limit and right hand limit, LHL and RHL. Okay. LHL, left hand limit. Let us see what is LHL. See dear students, when I said x is approaching a, x can be a value just lesser than a, or x can be a value just more than a, but we do not know whether it is just less than a or more than a. So to give more clarity, let us understand that x is approaching a from the left side. What is the meaning of it means? It means x is equal to a minus h, or we can also use delta, the symbol that we used before. So who is h means h is a real number, it is a positive real number. Okay now, h is positive and at the same time h is a real number and at the same time h is approaching 0. That means 0.000000 and so on. H value maybe 10 power minus 50 or 10 power minus 60. Okay now, the meaning of x approaches a minus means x is equal to a minus h. If you want to know the meaning of it, let me consider an example. For example, if I say that x is approaching 3 from the left side, what is the meaning of it means x can be equal to 3 minus h. When I say h is approaching 0, it can be 0.00000 and so on, 1, whose value if you subtract is 2.999999 and so on. Are you understanding this? So when I say that x is approaching 3 from the left side, I am not saying x value is 3. It is just less than 3. It can be 2.999999 and so on. So x value is equal to 2.9999 and so on. It is not less, it is not exactly 3. Please understand this. So I hope you understood the meaning of it. So when x is approaching a from the left side, it means that x is equal to a minus h, where h is positive real number and at the same time h is approaching 0. Now we will see. So dear students, when x is approaching a number, a real number a from the left side, even the function is approaching some number L1, where L1 is a real number. Okay, now when x is trying to become a from left side, f of x is trying to become a real number called L1. It can be L1 minus or it can be L1 plus, we don't know. So let it be L1. It can be from left side or from the right side. So then we write this mathematically as limit x approaches a minus f of x, which is equal to L1. So this limiting value of the function is called left hand limit. This is equal to LHL. We call it as LHL, which is also called left hand limit. And we can also write this as f of a minus. When input is just lesser than a, the output is f of a minus. Correct or not? So the left hand limit can be written as LHL or f of a minus, which is equal to limit x approaches a minus f of x. It can be some number L1. Similarly, let us also talk about right hand limit, RHL. RHL is right hand limit. See, same way, x is approaching a, this time from the right side. X approaches a from the right side. What is the meaning of it? The meaning of it is what? X is equal to a plus h, where h is what? As I told already, h is positive real number r plus, and h is approaching 0. Okay, now so instead of h we can also use this simple delta. Okay, whatever it is. Now you understood the meaning of x approaches a plus. Let us see what is right hand limit. So when x is approaching a from the right side, then the function f of x also approaches some number. Let that number is L2, where L2 is also a real number. It can be positive, it can be negative, it can be 0, it can be plus infinity, it can be minus infinity, whatever it is. So when x approaches a plus, f of x also approaches a real number L2. Okay, we write this mathematically as what? We write this as what? Limit x approaches a plus f of x. Limit x approaches a plus f of x, which is equal to. So when x is approaching a from the right side, then the value of f of x is L2. Okay, now so if you want an example just like for the previous one, so let us assume that x is approaching 3 from the right side, which means what is the meaning of it? The actual value of x is 3.000000 some number. Okay, now so x is approaching 3 plus. Okay, now then f of x is also approaching some number, so that number is called L2. Okay, so we will have examples to understand LHL and RHL better after this. So then this is called as what? Right hand limit, and we represent it as RHL. This is RHL, and sometimes instead of using RHL as word, we can also call it as f of a plus. We can also call it as what? F of a plus. Okay, now so this is LHL and this is RHL. Okay, so how to calculate LHL and RHL, and how to check whether the limit of a function exists or not. So to understand this better, let us go for an example. Let us take some examples to calculate what is LHL and to calculate what is RHL. Okay, so we have taken a function whose domain is any real number and codomain is also any real number. Okay, and the function is given by x plus 3. The function is given by x plus 3. Let us see how the function behaves at x is equal to some real number. For example, let us take x is equal to 5. Okay, fine. At x is equal to 5, all of us know we can calculate the value of the function. What is the value of the function, dear students? F of 5, which is equal to 5 plus 3, which is equal to 8. The value of the function is 8. Now the question is not about the value of the function. The question is about limiting value of the function. We have to understand what is limiting value of the function, right? So let us try to calculate what is LHL at x is equal to 5. Okay, so I am going to calculate LHL. So limit x approaches 5 from the left side f of x. So which means limit x approaches 5 from the left side, f of x is x plus 3. Please understand one thing, dear students. When I said x is approaching 5 from the left side, it means what? X is equal to 5 minus some number. Correct or not? X is equal to 5 minus some number h, where h is positive real number, and at the same time h is approaching 0. H is approaching 0. So what I will do is, instead of writing x approaches 5 from the left side, I will write h approaches 0. So I am changing the variable here. Then instead of x, we are going to write 5 minus h. Let me write 5 minus h plus 3. So this is equal to what? Limit h approaches 0. 5 plus 3 is 8 minus h. So what is the meaning of it, dear students? Now I can substitute h value as 0. You can substitute h value as 0 and you will get what? 8 minus 0, which is equal to 8. What is it trying to say is that when x is approaching 5 from the left side, f of x is approaching what number? 8. And if you want to know exactly whether it is approaching from the left side of 8 or right side of 8, please observe this. 8 minus h, where h value is 0.00000001, something like that, or 10 power minus 20, 10 power minus 30. Then 8 minus that particular number means what? 7.9999 and so on. Correct or not? So what is the meaning of it? 7.999 and so on means the actual value is 8 minus. The actual value is what? 8 minus. The original value is 7.999 something. But please understand the definition once again. When x is approaching 5 from the left side, f of x is approaching what number? We are talking about what? F of x is approaching what number only now? So is it enough to say that f of x is approaching 8? So left hand limit is what? 8. If left hand limit is 8 means what? When x is approaching 5 from the left side, f of x is approaching 8. But if you exactly want to know whether it is from the left side or right side, it is 8 minus something. So it is approaching 8 from the left side. But generally, while solving the problems, I will not write it as 8 minus, I will generally write it as 8. But it's important to know whether it is 8 minus or 8 plus while calculating limiting value of composite functions. So when we discuss about limiting value of composite functions, I will observe whether it is 8 minus or 8 plus. But for now, the answer is 8. Similarly, we can calculate what is RHL. So what is RHL? So we are talking about RHL. Then x approaches 5 from the right side. So 5 plus. Here also 5 plus. And then 5 plus means x is equal to 5 plus h only. X is equal to 5 plus h, where h is any real number, positive real number, and h approaches 0. So here also instead of x, I will write 5 plus h. And the answer is what here? 8 plus h. Then if you substitute h as 0, you will get 8 plus 0 and you will get 8. But h is not actually 0, correct or not? It is approaching 0. So the original value is 8 plus 0.0000 something. And the original value is 8.00000 something. So the original value is 8 plus. When x is approaching 5 from the right side, f of x is approaching 8 from the right side. But as I told you, while solving the problems, we generally won't write whether it is 8 plus or 8 minus. So we just write 8. Okay now. So in this example, what did we observe? We observed that LHL is equal to RHL. And obviously we also observed that LHL is 8, RHL is also 8, and value of the function is also 8. So in this example, left hand limit is equal to right hand limit, which is equal to value of the function. Correct? Let us take second example. So our second example is what? F is from R to R and f of x is x square. Okay na? Whose domain is R and the codomain is R. And we are trying to see what happens when the input approaches 2 for this function. How the function behaves when input x is in the neighborhood of 2. Please observe this. Are you understanding how I am bringing the word called neighborhood of 2? Okay, fine. First, what is the value of the function? F of 2. At x is equal to 2, the value of the function is 2 square, which is equal to 4. 2 square, which is equal to 4. That is the value of the function. Now let us calculate what is LHL, left hand limit. So LHL is equal to limit x approaches the number 2 from the left side, f of x. So which is equal to limit x approaches 2 from the left side, f of x is x square. Right? So and we know that when x is approaching 2 from the left side, it means x is equal to 2 minus h. Correct or not? And where h is approaching 0 and h is a positive real number. So I will write h approaches 0 and instead of x we are going to write what? 2 minus h whole square. Let us use a minus b whole square to expand it. Limit h approaches 0, a minus b whole square is what? a square plus b square minus 2ab. So you will get minus 4h. Minus 2 into a into b. You will get minus 4h. Correct or not? So which is equal to limit h approaches 0. 2 square is 4. And to exactly understand the value of this, let us do one thing. I will take h common. H into h minus 4. Please observe one thing, dear students. Let us try to understand the value of this, whether it is more than 0 or less than 0. H is a positive number, 0.000 something. It is positive number. And H is here also H is positive, which is 0 point something. 0 point something minus 4 is a positive number or negative number? Obviously negative number. And you are multiplying some negative number with 0.000000 and so on. First of all, positive into negative will be negative. This overall value will be negative. And obviously, what kind of negative value? 0.0000 something into some number will also be 0.00000 into something. So dear students, this entire negative value is approximately minus, let me take 10 power minus 30. I am just assuming, that's it. Are you understanding? The entire negative value is minus 0.00000 something. What is the meaning of it? So it is 4 minus 10 power minus 30, for example. What is the meaning of it, dear students? Which means that the answer is 4 minus. Correct or not? The answer is what? 4 minus. The left hand limit is 4 minus something. 4 minus 0.00000 something. So we generally don't write 4 minus or 4 plus. We will say that the left hand limit is 4. But if you want to say exactly whether it is approaching 4 from the left side or right side, then it is approaching 4 from the left side. But it's okay, we will not write this. We will just write that left hand limit of this particular function is 4. Similarly, you can calculate what is right hand limit. Can you do it before I explain it? Just pause the video and do it yourself and check whether you will get 4 minus or 4 plus. Try it yourself first and then check the remaining video. Okay, now as we are discussing RHL also, the right hand limit RHL. Then x approaches 2 plus f of x. So limit x approaches 2 plus x square. So x approaches 2 plus means x is 2 plus h. Correct or not? X is approaching 2 from the right side means x is 2 plus h, where h is approaching 0. So we know that a plus b whole square is a square plus b square plus 2ab. Then this becomes what? 4 plus h into h plus 4. Then dear students, h is positive. H plus 4 is also positive. Positive plus positive is also positive. So positive into positive. And particularly what type of value? Positive into positive is positive. And what type of value? H is 0.00000 and so on into some number is also 0.0000 into so on. For example, plus 10 power minus 30. It is a positive value. This entire value is positive value and its value is like 0.0000 and so on. So your final answer is 4 plus 0.0000 and so on. That means your answer is 4 plus. Okay, when x is approaching 2 from the right side, f of x is approaching 4 from the right side. Okay, na? But generally it doesn't matter whether it is from the left side or right side. We say that RHL is also 4. We got LHL as 4. We also got RHL as 4. So therefore in this example also, dear students, LHL is equal to RHL. Both are equal to 4 and even the value of the function is also 4. It is equal to f of t. Even the value of the function is also 4. So in the second example also, left hand limit is equal to right hand limit, which is equal to value of the function. Okay. Now let us take third example. Okay. In third example, I have taken a piecewise function. If your input is not equal to 2, then f of x is equal to this function. And if your input is equal to 2, then f of x is equal to 3. I hope you understood this. So dear students, when you simplify f of x, what happens? F of x, particularly this function, f of x is equal to x square minus 5x plus 6 divided by x minus 2. So when you factorize the numerator, you all know how to factorize the numerator, right? I cannot explain factorization detailedly. I will find time some other day. How to explain factorization, I will discuss in some other video. For now, x square minus 5x plus 6, if you factorize, you will get x minus 2 into x minus 3 divided by x minus 2. Dear students, please observe one thing. The question is, can I cancel x minus 2 here and here? Obviously, f of x is equal to this function if x is not equal to 2. Correct or not? F of x is equal to this function if x is not equal to 2. X is not equal to 2 means x minus 2 is not equal to 0. X minus 2 is not equal to 0. This is not a 0. This is not 0. So I can cancel x minus 2 and x minus 2. I can cancel x minus 2 and x minus 2. I can simply write x minus 3. I can simply write what? X minus 3. So therefore, dear students, this function is nothing but x minus 3. This function is nothing but x minus 3. Okay now? So anyhow, here we are talking about left hand limit and right hand limit. Correct or not? So let me take left hand limit. LHL is equal to limit x approaches at what number? I am sorry, I didn't mention. We are discussing about limits at what number now? We are talking about limits at x is equal to. We are talking about limits at x is equal to 2. So let me see what is left hand limit at x is equal to 2. X approaches 2 from the left side. The function is x square minus 5x plus 6 whole divided by x minus 2. In the next step, so we will write the factorized form of numerator. The factorized form of numerator is x minus 2 into x minus 3 whole divided by x minus 2. Now the question arises, can I cancel x minus 2 and x minus 2 or not? Dear students, if x is equal to 2, I cannot cancel these two. But x is not equal to 2. X is only approaching 2. What is the original value of x here? It is actually 1.9999 and so on. Correct or not? It is not exactly equal to 2. Since x is not exactly equal to 2, this value is not exactly equal to 0. So for that reason, I am cancelling these two. Please understand this. This is very, very important. Next, what we got here? So we got limit x approaches 2 minus x minus 3. Now you can substitute x as 2. Whether it is 2 minus or 2 plus, you can substitute x as 2. Only when you want to know whether the answer is approaching from the left side or right side, then you have to write x as 2 minus h and r. For now, you can directly substitute x as 2. So 2 minus 3 which is equal to minus 1. So therefore, dear students, when x is approaching 2 from the left side, f of x is approaching minus 1 from the left side. So therefore, the LHL value is minus 1. LHL value is minus 1. LHL is equal to minus 1. Similarly, you can try what is RHS rate. It's very easy. What is RHS? Sorry, RHL, right hand limit. X approaches 2 plus, same function. X approaches 2 plus, same function. Once again, when x is approaching 2 from the right side, its actual value is 2.000 something. Correct or not? It is not exactly 2. It is 2.00001 something like that. X is not exactly 2 now. So I can cancel these two. Then I can write x minus 3. So x approaches 2 plus x minus 3. Now we can substitute x as 2. So what you will get? Minus 1. The answer is what? Minus 1. So even the RHL is also minus 1. The RHL is also minus 1. And what about the value of the function? The value of the function, when input is 2, the value of the function output is 3. Okay now? So dear students, in this example, what did we observe? We observed that LHL is equal to RHL and not equal to value of the function. Left hand limit and right hand limit are equal, but they are not equal to value of the function. What is the meaning of it means? Let us try to understand the meaning of it using graph. Okay na? Dear students, let us try to draw the graph of this particular function f of x on the coordinate axis. So when input is 0, of course, this is nothing but x minus 3. Correct or not? This is nothing but x minus 3. When input is 0, the output is 0 minus 3. The output is 0 minus 3. When input is 0, the output is minus 3. When input is 1, the output is 1 minus 3, which is equal to minus 2. When input is 2, the output is not, we should not substitute here. When input is 2, the output is 3. Okay now? When input is 2, the output is somewhere here. But dear students, when input is just lesser than 2, for example, let me take 1.9. When input is 1.9, when input is not equal to 2, 1.9 is not equal to 2, we can substitute here only now. 1.9 minus 3, that is actually x minus 3. Okay now? I can substitute here only now in place of x 1.9. So 1.9 minus 3 is what is it, minus 1.1, correct or not? Minus 1.1 means somewhere here, minus 1.1. When input is just more than 2, what happens? When input is just more than 2, 2.1 for example, 2.1 minus 3 is minus 0.9. So it is actually a straight line. Let me say, when you look at these points, it is actually a straight line. And when input is 3, the output is 0. So it goes like this. The graph is actually a straight line. When input is 3, 3 minus 3 is 0. So the output is 0. So I have located all those points. All of you have learnt how to draw the graph of f of x is equal to x minus 3 in 10th standard, correct or not? Y is equal to x minus 3. So this is the graph of y is equal to x minus 3, or f of x is equal to x minus 3. But the only thing is, when input is equal to 2, the output is not equal to minus 1, because I cannot use this function. When input is exactly equal to 2, the output is not minus 1, the output is actually equal to 3. So please understand one thing. Left hand limit, when x is approaching, when the input is approaching 2 from the left side, this side, the output is also, the output means through the graph, the output is approaching what number? The output is approaching minus 1. When input is approaching 2 from the left side, the output is approaching what number? Minus 1 from the left side. Similarly, when input is approaching 2 from the right side, when input is approaching 2 from the right side, the output is approaching the same number minus 1 from the right side. That's why left hand limit is minus 1, right hand limit is minus 1. But what is the value of the function? When input is exactly equal to 2, it is not minus 1, it is 3. Are you understanding this? See, the function is trying to become minus 1 from the left side, the function is trying to become minus 1 from the right side also, when input is approaching 2. But when input is suddenly 2, the function does not become minus 1, it becomes some other number 3. Okay na? Fine. So LHL is equal to RHL but not equal to value of the function in this example. Let us take one more example. Example number 4, and we will conclude whether the limit exists or not. We can conclude based on that. So we have taken a function from R to R whose domain is R and codomain is also R, real numbers. And the function is signum function, and all of you know what is a signum function. Signum function is what, according to its definition, what is signum function means? F of x is equal to, the function f of x is x mod x by x. The function f of x is mod x by x. When it is mod x by x, if x is not equal to 0, and f of x is equal to 0 if x is equal to 0. If you want to understand it even better, dear students, when x is negative, we all know that mod x is minus x, correct or not? Mod x is minus x by x is minus 1. And when x is 0, obviously the output is 0. And when x is positive, mod x is plus x by x is 1. So this is signum function. F of x is equal to minus 1 if input is negative, 0 if input is 0, and 1 if x is positive. So for this function, let us try to discuss about limiting value of the function at x is equal to 0. Limiting value of the function at x is equal to 0. So first of all, value of the function f of 0 is 0. Left hand limit shall I write like this? F of 0 minus left hand limit. At x is equal to 0, we are talking about limiting value of the function at x is equal to 0. Okay na? So left hand limit, this is left hand limit. When your input is just lesser than 0, it is a negative number or a positive number? Just less than 0 means negative number only na? So your input is negative means what is the answer? Minus 1. Therefore our left hand limit is equal to minus 1. Similarly, what is right hand limit? We can also write right hand limit as f of 0 plus, correct or not? This says that input is 0 plus something, which means what? Just more than 0. When input is just more than 0, it is positive number, right? Your input is positive, the output will be plus 1. So dear students, in this example, what did you observe? Left hand limit is minus 1 and right hand limit is plus 1. LHL is not equal to RHL. So in fourth example, we observed that LHL is not equal to RHL, correct or not? So we had 4 examples totally. Now let us understand in which examples limit exists and which example limit does not exist. Dear students, when can I say that limit x approaches a f of x exists? When can I say that limit x approaches a f of x exists means if left hand limit is equal to right hand limit at x is equal to a. If the left hand limit at x is equal to a is equal to right hand limit at x is equal to a, then we say that limit of the function exists. It doesn't matter whether they are equal to value of the function or not. I don't care whether LHL is equal to RHL, whether they are equal to f of a or not equal to, it does not matter. If left hand limit is equal to right hand limit, we say that the limit of the function exists. So obviously in the first example, left hand limit is equal to right hand limit, correct or not? In second example also, left hand limit is equal to right hand limit, and even in third example also, left hand limit is equal to right hand limit. So in first example, if you see, I think you have taken the notes. In the first example, limit x approaches 5 from the left side, f of x, which is left hand limit, is equal to limit x approaches 5 from the right side, f of x. Both are equal to how much we got? 8. Therefore, what is the limiting value of the function in first example? Therefore, we can say that limit x approaches 5, f of x is equal to 8. That means it doesn't matter whether the input x approaches 5 from left side or right side. In both the cases, the function is trying to become 8. So therefore, we can say that left hand limit is equal to right hand limit, both are equal to 8 means when x approaches 5, f of x is approaching 8. From left side also it is approaching 8, from right side also it is approaching 8. Therefore, when x approaches 5 from both sides, the function is approaching what number? 8. That's it. So the limiting value of the function in first example is 8. Similarly, in second example, what is the limiting value of the function? In second example, we observe that LHL is 4 and RHL is also 4. Correct or not? When x is approaching 2. So therefore, we can conclude in second example that limit x approaches 2, x square is equal to 4. Limit x approaches to x square is equal to 4. In second example also limit exists and it is equal to 4. What about third example? In third example, we have seen that LHL is minus 1 and RHL is also minus 1. So we can conclude that limit x approaches, what is that number? I think the number is 2, yes. Limit x approaches 2, f of x is equal to minus 1. In third example. What about fourth example? Only in fourth example, left hand limit is not equal to right hand limit. Correct or not? In fourth example. So in fourth example, we observe that left hand limit is minus 1 and right hand limit is plus 1. Since left hand limit is not equal to right hand limit, we say that limit x approaches 0, f of x does not exist. Since left hand limit is not equal to right hand limit, dear students, we say that limit x approaches 0, f of x does not exist. The limiting value of the function at x is equal to 0 does not exist. Why limit does not exist? Because left hand limit is not equal to right hand limit. There are many more examples. We generally assume that the left hand limit should always be a finite number and right hand limit also should be a finite number. It's not like that. If LHL is approaching minus infinity, let LHL is infinity. We are saying left hand limit is what? Approaching only, not exactly equal to. I can write like this. LHL is equal to minus infinity means the function is trying to become infinity. Similarly, if RHL is also infinity, when LHL is infinity and RHL is infinity, LHL is obviously equal to RHL. LHL is obviously equal to RHL. We say that limit exists. At that time, we will write limit x approaches 0, f of x as infinity. If LHL is minus infinity and RHL is minus infinity, then we say that limit exists. Limit f of x approaches that particular number, f of x is minus infinity. I'll talk about this particular case. When LHL is plus infinity or minus infinity, RHL is plus infinity or minus infinity, whether limit exists or not in those cases. So I'll discuss the limits for those functions in next video. Okay, now I'll take more examples. We will see how to find LHL and RHL in those examples. We will check whether LHL is equal to RHL or not. We will check whether limit exists or not in those examples. So dear students, I hope you understood when limit exists and when limit does not exist. I hope you understood. So limit of a function exists only when its left hand limit is equal to right hand limit. We will not worry about value of the function. Okay na? So I hope you understood this particular concept of introduction to limits. See you all in the next video.